Testing. 1, 2. Oh, there we go. Now it's working. All right. Okay. Good start. Good start, Mark. I was just doing all these movements and stuff like that, and nothing was happening. Okay. We can hear you now, right? Okay, good. Everyone's saying yes. I think I had a moment where I had to do something. I had to do another meeting or something like that, and then I changed my microphone settings and stuff, and I hadn't done anything. Okay, apologies. I have burnt the first 2 minutes of the lecture just fixing my audio, but hopefully that's good. I was saying that I have to go full hype for Friday afternoons because the 4 to 6 p.m. lecture is like, there's that time of the week where you're just like, oh, I'm just gonna wind down for the end of the week, but we have to get hype because we've got 2 hours where we're going to learn bits about programming in C and stuff like that, and it's interesting stuff. It's stuff that we want to know about, so we've got to get hyped back up for it. So that's what I was doing at the beginning, only there was no sound, so there was no hype. Anyway, let's do this. So last lecture, we were talking about debugging. So we were talking about ways to identify the problems that are happening in your code. And I really wanted the emphasis for what I was talking about there to be on not just sort of looking at the code and go, oh yeah, there's the problem, no worries. Because we don't really want that solution. We don't want the solution for when things are easy. We want the solution for when things are hard. And when things are hard, what you want is a process that you can follow that's going to help you identify solutions. So hopefully some of the stuff I showed you there, using compilers to systematically take down bugs one at a time, using testing to isolate bugs and narrow in on things, that kind of thing is the kind of techniques that you're going to be using through an entire career of programming. I mean, they're useful even if you only use them in 1511. They'll get you more marks in your assignments. But they're the kind of things that we never stop using. Those kinds of tricks to pull apart our own programs and find out what's going wrong. And we also introduced a new variable type, the char, which is the character, which is basically any key that you can press on the keyboard, but even more than just the keys on the keyboard. Originally, it was just the keys on the keyboard. And they're allowing us to now open up the values that we can store beyond just the numbers that we've been using, the ints and doubles, and now into letters. We didn't do any demos with that, but today we are going to. So I'm going to add some more onto that today. We're going to, I guess we don't have to say continuing characters because we looked at it, but I actually copied the slides into this slide deck just in case we wanted to talk about it a little. So we're continuing characters, and then we're working on strings. Strings are basically arrays of characters. There's a little bit more detail than that I'll tell you about, but the idea is that us as humans, we very rarely use letters on their own. We're very much more often, if we ever use letters, we're using them in collections, in bunches. So words or sentences and things like that. And so we're really going to be using strings more than we're going to be using characters. So it was hardly worth actually doing a demo with single characters, but now that I add the second concept, arrays of characters, which shouldn't be too hard, I think, for everyone to understand, because we've been working with arrays a bit now with numbers. So if I just change a number to a character, should hopefully click with everyone. But there's details in it because words act very differently to collections of numbers. And so we're going to be using them in that context. We're also looking at command line arguments, which is very much connected to strings. It's the idea that if we want to, we can actually type in information to our program before it runs. So everything that we've been doing so far with scanf has been after the program starts running, you can then type in stuff and get information into your program. Command line arguments allow us to set things up as the program starts. So this is actually the command line, as we call it, as in you type in the commands in the command line. You can actually put some letters and words and numbers, well, just anything after the program name, and then they'll be fed into the program. So this is the only way, well, I don't think it's actually the only way, but for us, it's the only way that we can actually have a main function that has inputs. So I'll show you how we're going to use that, and we'll do a demo today that uses all of that. Okay, so I've got someone's asking for a chicken update. Chicken is asleep somewhere at the moment. She usually will come out sometime during the lecture, so she might say hi later. Someone was asking... Oh, people are asking about week 6. Week 6 is like flexibility week, which is a week that has no official content in it. We've moved all of the deadlines for 1511 outside of flexibility week. There's no tutes or labs next week as well. It's good to point that out. And the lecture slots will have stuff in them, but none of that stuff is official course content. So one of the 2 lecture slots are probably just going to do a bit of a Q&A, which is just like, is there anything that people have had trouble understanding? We'll just go over it again. I'm actually get some of the tutors in to be guests there, because like they always like getting involved, stuff like that. And another one is going to be a lecture that I've given before, which you can probably see recordings of, which is a professionalism. It's a talk about kind of what it means to be a professional rather than just learning about how to program computers. So it's a very much wider topic. I mean, one could say that it's more important than anything that I'm teaching you in 1511, but it's also not part of the curriculum for 1511. So that's how it's that's how that one kind of goes. That will, I think, be on the Friday, but I will I'll let you know in the Monday notice how the Wednesday and Friday how we're planning them out. Okay, cool. So let's go on. So characters, we talked about this before, and the interesting thing is that a lot of the time when we're using a character, we're actually going to use an integer if we're using a single character. And this is always going to remind us as well that every character is just a number, but the way you think about it, if you think about it as a letter, you can translate it kind of from the number it is to its ASCII value. So A has an ASCII value. I think we saw that it was the value 97. And then we can use them as those numbers. The reason we're often using integers whenever we have single characters is when we're using something like getChar, which is a function that helps us read integers. GetChar might give us this EOF symbol, which usually will be defined. This depends on the definition of the constant in the standard input-output library, but I very much doubt that the standard input-output library is going to change those constants. But, you know, we don't assume. So we just use the EOF symbol, but we do use an integer because we know that the EOF symbol is usually a -1. So I can have an input character and I can do getChar on that and then print it out. If I wanted to continuously test that to see whether it worked or not, I could test it against that EOF, but that's only going to work if I use an integer. If I use the char variable, the char actually only goes from 0 to 255, so it won't be able to store the -1. It will do 254, I think, if you go -1. No, 255, I think, because 0 and then -1. You'll end up at 255, and then you won't know whether it was an EOF or not, because it will no longer match. So that's that integer underflowing thing I talked about much earlier, where since this thing can only store values between 0 and 255, if I take a 0 and I -1 from it, it would just go all the way around to the top and then come back down from the highest number. So that's why we're often using integers when we're processing input, so that we can receive kind of signals from the input reader as to whether things have worked or not. So my input char is an integer. And then if I wanted to do this kind of thing where I'm looping through, I'm skipping through these slides because I talked about them on Wednesday, but I still want to talk about them a bit to recap what we're doing. If I was wanting to read multiple characters, I could just keep reading characters and say, if I didn't get this end of file, then I'm going to assume that I got an actual character. So I keep doing getChar, and getChar, the function, if you go and look it up in any websites and stuff that talk about the C standard library, or even the manual pages in Linux, they should be able to tell you a bit about getChar that says, I will give you, as my output, I'll give you the character that I read, but if I didn't read a character, I will give you the EOF symbol. So if I don't get an EOF, I assume I have a character and I can do something with it. C-type pretty handy little thing. A lot of the things that you could think of to do with individual characters are already in here. So I would suggest that if you're starting to fiddle around with working with characters, which probably not yet, because I only spoke to you about it on Wednesday, and we've got a break for a week from tutorials and labs, so the first time you're going to see these in practical work that you're going to be working on isn't until week 7. So as always is the first kind of lab and tutorial the week after the lecture is where we work on it, but since week 6 is not official content, we won't be working on characters and strings until week 7 labs. But anyway, anytime you're working with characters, there's a lot of these nice little functions which will give you some information about them or allow you to change them and things like that. I think it happens a fair bit that there are things that we think of that we want to do, and then if we look in C-type for characters, we might then see already in there's something that does the task for us, so we can just use those functions instead. What are people talking about there? I'm just going to assume that Rani's got that covered. Looks like there's a lot of conversation going on in there, but I assume that Rani's got it. Yeah, someone was asking you about due dates and stuff like that. Yeah, so what we've done is we've just pushed back the Lab 5 due date. So instead of it being due on Monday in week 6, which kind of doesn't work because that's like really smack bang in flexibility week, and especially bad for anyone who has a Friday lab, so we just pushed it a week later. That does mean that the assignment and the lab are due at the same time, but we are kind of expecting people to mostly have the labs finished in week 5 rather than be working on it continually into week 6. So hopefully, like, there's always pressure in week 6, and I think you'll be getting that from your other subjects as well, the assignment pressure in week 6, but the lab, hopefully that deadline happening at the same time doesn't cause too many problems for people. If it does, this is a slight side thing, you can always throw one lab out of the 10 weeks of the term. There's only 8 marked labs, and we'll only mark 7 out of those 8. So the first week's lab wasn't marked, and week 6 obviously doesn't have one, so there's 8 total, but we're still only going to mark 7 out of those 8 remaining. So if you do need to throw one, sometimes at the time where you've got a massive assignment due is the time that you want to throw one. Although maybe you want to think about the second assignment, not the first one in that case. Okay, moving on to what we're talking about today. When we put characters together, so words, sentences, and things like that, the technical term in C that we're going to use for these things are strings. And strings are interesting because they're the first variable type that I've kind of given you that isn't actually its own type. Like, you know, a pointer is very much its own type. A double or an int, very much their own types. An array is a type as well. But it's sort of a type. It's a type that's related to other types. But a string is not a type. It's just an array of characters. So if I wanted to be really technically correct about how we're programming in C, I would never use the word string. I would just say arrays of characters. But the word string is something that's very, very well understood. We use it a lot and we know what it is. So it's the kind of thing where you will hear this talked about a lot, the idea of a string. Plenty of other programming languages have explicit formal types that are called strings. So you can type the words in string into a programming language and it is a keyword. In C, it is not a keyword, it's just a concept. So it's an array of character variables. So words, sentences, great huge passages of text can be stored in strings, because, you know, you've seen me do it before where I've just gone, oh, I could make an array that's got 1,000 characters, 1,000 integers or something in it, right? And so I could do the same thing, and you can do arrays with like tens of thousands of characters if you want to, and store a whole novel in there. So from things as small as words to much larger things, same way that we can use arrays of characters. There is one difference though. So the way that we would use a sequence of numbers or a collection of numbers, it's usually going to be really, really defined how many numbers we're going to use. But if I say to you, I'm going to store one word, so I'm going to store a word in an array, I think one of the first things that you'd be asking me is, well, how long's the word? Because I don't know how long the array needs to be if I don't know how long this particular word is. Because one word can have lots and lots of different amounts of letters in it. So what we're going to be doing a lot, and I showed you this concept before, but we didn't really delve deep into it, but we're going to start to use arrays that are too big for what we need. So I did do this once, but we're going to be starting to store things like strings in longer arrays than they are, and we're only going to be using like the first, few letters of it or something. Strings have a particular mechanic for that, where they actually have a character that doesn't, that is not visible, will never be printed out, and it does not have doesn't have a letter attached or anything, but it is a valid character, and that's this thing called /0, which is we call it the null terminator. I love that name. It's the most epic name for just like a character that doesn't really do much. Activate the null terminator. I had to drink for that, it's very important. Okay, so what the null terminator does is it goes at the end of any string. So a string is actually not considered a valid string unless it has the null terminator on the end. And the null terminator says, this is the end of the content, right? So I've got all my letters in there to spell out the word, and the null terminator says, this is the end of the content. The rest of the stuff in this array must be ignored. So when my computer is looking through the array and it hits the null terminator, then it should stop and go, okay, no, I've read all the letters that are there. When we write things for it, when we write while loops and stuff like that to go through a word, if we hit the null terminator, we should be stopping there, because anything we read past the null terminator is basically, it's deemed to not exist. In a sense. So that's our way of saying we will use the space up until this null terminator, and then afterwards we won't use anything. We can move the null terminator around, so if we're going to replace a word with a word of a different length, then the null terminator will move somewhere. But let me show you, because I've got some diagrams here that just sort of make it a little bit easier to understand. But what we're starting to deal with is the fact that we don't necessarily define the length of all possible words in advance and make one array for all possible words. So we can actually do this weird thing, which is, been highly not recommended for everything that we've been doing up until this point, is to actually have an array that doesn't have a length to begin with, but the initialization gives it its length. This is okay, but potentially dangerous, because this means that if I wanted to change the word from hello to goodbye, then suddenly this array doesn't have enough length to deal with it, and nowhere in here have I measured the length and stuff. So what we'll often be doing instead of the open brackets like this is we will define a maximum size of our word somewhere as a constant, and we'll make the array that size and then fill it with just this stuff. So this is building arrays of characters, which we will be calling strings, but here you can see that it's an array of characters. So we're using the new character variable type, and we're using the array declaration, which is like creating an array, and the initialization. We've seen this before. So if I put these letters in, and remember, single quotes for single characters, here, this will put individual characters in, and I've put a null terminator in to make sure it's a valid string. But we actually have a much easier way to do it, and you will recognize this because we've been making strings the whole time we've been in this course. We just haven't been calling them. Actually, I've called them strings a couple of times, just on instinct, by accident. But this string here, both of these initializations will create the same type of array in memory. So they will both be character arrays. They will both be exactly long enough to fit what they need. So this way we can create things that are an exact size without specifying the size. But again, I give you a warning that that might be dangerous. And we've got 5 visible characters, and both of these will have the null terminator on the end. So the interesting thing about using the double quotes for strings is they assume that the string is well formed, and they will make sure that it's well formed. So in all our printfs that we've been doing with these strings, we've never put a null terminator on the end. But C has been putting null terminators on the end of all of these every time we've been making them. Someone's asking there, Rich Russian Boy, that's a pretty funny name, has been saying, what happens if we do not add the null terminator? Well, a whole lot of things will break if you don't add the null terminator. So anything that's expecting a string to finish in a certain way will keep going through the array somewhere, or it will try to go off the end of an array. So if I created this one without the null terminator, and then I sent that thing into a printf or some other thing that's a really specific string-based function, it might crash at that point because it won't know where this thing ends, and it will read off the end of the array. Or it'll read further into the array and into some other data that we had there previously. There's this whole lot of what we call undefined behavior that can happen in programming that can get really, really messy, because this thing could read past the null terminator into an array. Let's say that this array was longer than the word hello, and then it will start to read other words that we'd previously put in there that we'd overwritten only the first bit of, and then we'd start printing out all this extra information. So a lot of weirdness can happen there. So we talked about getChar and putChar being functions made specifically to pick up and put down a single character at a time. So write a single character to our terminal or read a single character from our terminal. Now I give you another one called FGets. And what FGets will do is it will grab an entire line from your standard input. So you can type in an entire line and press enter. And this is something that we haven't really been able to do up to this point with scanf, because when we've been doing scanf, it's been like, pick up this symbol and pick up this other symbol. So we could do something like scanf multiple integers, or scanf an integer then a double, then an integer and a double, that kind of thing. But anytime we used scanf like that, it was always going to ignore spaces. It was going to ignore spaces, and it's going to ignore the enter key and stuff like that, which means it wasn't actually picking up everything that we've been typing in. If I want to be really, really sure to pick up everything that we're typing in, I can do something like FGets instead. But in order to do that, I had to have characters, because FGets is going to have an array of characters, and it's going to have a length which is going to say, okay, this is how much I could possibly take in, and the stream it's getting information from. This is like future thinking. We will have multiple ways of getting information. So if we think about the idea of using a computer, we could get information from files on our computer. And I think some people have already been working with that, because you can build test case files in Slide and have them be used as input into the program. So you have actually kind of been using some file streaming stuff, but not necessarily the full file streaming. And you could also have streams that are network connections and stuff like that as well. For the moment, the only stream we're going to be using in 1511 is standard input, which is the user typing it in. But know that these are actually optional. You can change them to other things. But we're not going into that yet. We'll get there eventually. But basically, the way we're going to think about this is the array we're going to put stuff into. So we have a string, an empty string or something prepared to receive the information. And the length says this is the maximum number of characters that I could read. So when we have the length in our FGets, we want to make sure that that length is the amount of space that we had available in that array. Because if we have this length longer than the amount of space we have available in the array that we give to FGets, we could potentially cause index out of bounds errors and stuff like that. So this is our way, like pretty much all functions we've been using arrays, we've said the array and we've said the length to let the function know how far they can go safely into this array. So we can do something like FGets, and this is an example of something that will read a line of text and then write it back out. So it's not that different. So fputs is the opposite of FGets. So we're using these stream names. Standard in is the stream of us typing stuff in the terminal. Standard out is the stuff that displays stuff to the terminal. So fgets takes a line in from the terminal, and fputs gives a line back to the terminal. So this demo code, if you just put this in a main somewhere, all it would do is would just loop forever. And every time you type in a line, it will type that line back out to you. But this is just showing us that we can take a line, we can store it in a string using fgets, and then we can output. The thing that we're getting here, though, is we can actually test this as well. So FGet, it does have an output. So if I remember correctly, FGet, I think, is a pointer output, because it's potentially going to give us a null pointer. So I think I can't remember where the pointer aims, but I think that if it gives us a null pointer as output, it's telling us that it did not receive any input. So this is if we do Control D, or we reach the end of file, if we're coming from a file stream or something like that. So this thing would just keep printing out lines until at some point it doesn't read input, and at that point FGet's output will be null, and so this while loop will stop. So this is an example of a piece of code where if I was wanting to just keep reading lines of input from my user and doing something with them, this is the kind of while loop I would use. So I would have something to store their input, something that checked that they were giving us input, and if they were giving us input, we process it. If they weren't giving us input, we stop the while loop, and we keep going with whatever else we're doing with our program. There are also a lot of helpful things in the string library. So I showed you the C-type library. I actually had that highlighted in pink in the other one, so maybe I should change that here, but don't worry, it's the same letters anyway. But there is a library called string.h, and that has a whole bunch of functions that can work with strings. One thing to note, if you look at the documentation for this, all of the input strings that we're getting for the string library will be given as character pointers. Yes. And this is like the perfect, because like Rani's like, hey, answer this question. The question there from Sarah K is, what is the difference between the length in the function and the null terminator? Well, the interesting thing about all of these functions is they will take a pointer only to the first letter. And they will actually not care. They don't care about what the length is. A lot of them won't ask for length. And you'll be like, how can we work with an array of things without length? And that's where the null terminator comes in. So we have a function now that will take in a pointer to the first letter of a string, which is basically a pointer to the string itself, because if the string is an array of characters and we have a pointer to the first letter, that's actually the same as giving the array in and of itself. The thing is, we don't know how long it is, so we don't know when to stop, except we've got the null terminator. So string length is just going to loop through, like, I don't know if it's exactly the code it uses, but I'm pretty sure it is. It's going to loop through the list until it finds the null terminator, and it'll say, okay, that's how many letters are in this list. So this is like, this was, I think this is a lab question at some point, us asking you whether it's possible to just throw an array into a function and have the function tell you how long that array is. And there's no real way, because there's no actual bounds on the array that tells you what's how. I'm sorry. I don't know if was that this week? Am I spoiling labs? I don't know if I'm spoiling this week's. Oh no, wait, it's Friday. It's Friday. All the labs are done. I'm not spoiling the labs. It's good. When you have strings, the strings actually have a symbol that say when they end. And because they have a symbol that says where they end, you can actually count the length of it. And this is not the length of the whole array. This is just the number of letters that we get in the string until we reach the null terminator. So you can have storage for a string, a character array that has like 100 letters in it. And then I put the word hello in there and a null terminator, and I say, what is the string length of this string? It'll be 5. HELLO, and then the null terminator. So even though the array itself had more space in it, string length says, no, how long is your string, using the null terminator. And all of these things are going to be able to work with only access to the memory location of the first letter, and they'll be able to work with these strings on the assumption that we've built the strings correctly. So if we haven't built the strings correctly, and we don't have a null terminator on the end of them, all of these functions will blow up. None of them will work properly, because all of them are expecting the null terminator to tell us where the end is. So hopefully that actually answers several people's questions there, because there was a question there about what happens if we don't have a null terminator. There was a question there about, like, is there a length, and is the length based on the null terminator? And yes, it is. Basically, the index of the first null terminator that's seen in the array is the same as the size of the string. I just had to make sure I was correct by that. He's like, is it size -1, or is it size +1? I'm pretty sure it's size. Yeah. So hopefully that answers all of those questions. So yeah, so we've got all of these kinds of things we can do in the string library. Just checking if there's any other questions. No, that's okay. All right. So that's the stuff that we can do with strings. I think we'll see more of that once I do demos of the strings, but I want to talk also about command line arguments. So these I do with strings because most of the time command line arguments are strings. So the command line is, hang on. I'm just shortening it there to make it easy. This is the command line. So right here is the command line. This is where the commands go in, right? Because we type in things and they're commands. I won't press enter here because obviously this isn't a command. Well, this would be interesting if it is. No, command not found, but you know, that's it telling us this is the command line. Bash is the name of the program that runs the terminal. So it's saying this is not a command. So you typed in the command this, but there wasn't something there. But if I type in ls, ls is a command, and ls will give me a directory listing. You know, so this is what's called the command line. And so if we go to what are we in? We're at lecture 10. Oh, I've got a command line arguments demo here. I'll show that to you in a second because I want to talk a bit more about it. But if I had a program in here, let's just go to lecture 9. So I've got character demo and debug. I could type in debug to run it. And I could type in this extra information. Now, when I do this, nothing's going to happen. So I'll just exit from that. But if I've set up my program the right way, this extra information that I'm giving here actually gets put into the program. So it actually gets given to the program as strings. So each of these is going to be a separate string that gets given to my program, and I will be able to use that information to do things. So I need to show you how we do that. So I'll go back to my slides. I'll talk about that a bit, and I'll show you the demo. So this is exactly what I was typing in here, /program extra information. So this is the command line, and this is the stuff that we could type in. And you note that, like, even though my program wasn't set up to take this extra information, it wasn't complaining that it existed. Because C kind of knows that chances are you're going to type in other stuff after the program name. And for example, I could do like this. So cd is a command. That's actually very similar to us just typing in / in the name of our program. And then I've said, here's my extra information. So if I'm going to write a program that works like change directory, then I would need some way to grab this extra piece of information and use it. So that's me just going to the current lecture 10 directory. We'll talk about that in a second. Okay, so this extra text can be passed into our program as strings, and we do that with this line here. I have a meme. Let me just... There is nowhere to put my face. Okay, I'm just going to go in the other corner for the moment. We're going to talk about this meme because I like this meme, the American Chopper argument meme. So, int main's always void. No, it's not always void. Then what is it? argc and argv. Those are arguments, right? So I just love it. These guys get really angry. I've used this meme for lots and lots of different things over the years. Okay, so main does not have to have the void input parameters that we've just sort of assumed and used again and again and again for all of our programs up until this point. If we want to, we can put these bits of information in here. And so I'm saying these bits of information, they're always exactly this, right? So if we want to take command line arguments, it has to be this exact layout of variables or else it won't work. So it's int argc and this crazy little construct here, character pointer array argv. So note that a second ago when I said if I had a pointer to the first letter in a string, I will have everything I need for the string because the null terminator tells me where it ends. This is an array of those character pointers. So think of an array. An array is a collection of identical variables, and if each one of those was a pointer that said somewhere else in my memory somewhere there's a string, and it has to be somewhere else in my memory because I don't know how long those strings are. So I can't just pack them all into the array itself. So this is kind of a two-dimensional array and also kind of not. So it's an array of pointers, but they're not necessarily all smashed together into one two-dimensional array because all of the arrays inside are not the same size as each other. So it's an array of pointers, and each of those pointers leads us to a string. And this one says how many things there are. So argc, which is argument count, will tell you exactly how many words were typed in on the command line. So that includes the name of the program, by the way. The name of the program is actually the first thing that is the first element of this array of strings. So you can actually think of this as an array of strings if you want. It actually works exactly as an array of strings. If strings themselves were actually self-contained things, this would be that. Then argv is the actual argument values, which is the actual stuff. So argc tells you how many things there are, because this array here, we don't know how many things are in it. And because it's not a string, there's no null terminator to tell us how many things there are. So we need to know how many there are. And then each of these is a string inside this array. So it's an array of strings here, which means that we can then use these things if we want to. So simple example here of using arguments. And I thought, as an example of using arguments, I might as well have an argument with my computer. So, oh, hey Shrey, how's it going? So this is the computer having an argument with you, where what it will do is it will say, it will take in whatever you type in the command line, and it says, well, actually, because that's how we start all our arguments, right? Well, actually, this program, so argv0 is always going to be the name of the program because it's going to be the first thing you typed in. So for this program to run, it always will have argv0, if it has argv at all. Argv0 will be the name of the program. So it's saying the name of the program says there's no such thing as, and then it loops through the rest of the arguments up until less than argc, because argc is the number of them, and it goes through those strings and it prints out all the strings that were typed in as the input. Hamish, well, actually, I start all my arguments with, oh wait. Someone asked me how many subscribers I have. I think you're talking about YouTube. I checked earlier today, I have 999 subscribers, so if one more person subscribes, I will become a YouTube partner. I don't know what that means because I have not tried to monetize this channel or anything like that. But I think that means I get some kind of officialdom. Thank you to whoever just subscribed. It's not important, by the way. It's got nothing to do with it. The YouTube's just a vehicle for me to make sure that I can do online lectures. So one of you is the magical 1000th subscriber. Oh wow. And everyone's getting held for moderation by telling people to subscribe because YouTube's careful with that stuff. Anyway. Okay, so let's look at this thing running because we want to see how this thing works. I have to ignore the fact that this has turned into a, what do they call them? Like those subscriber drives and stuff that people do on Twitch and stuff. Okay, let's look at the code. It's actually slightly different from what's in the slides, but I actually prefer the code like this because I like the integer to be right next to the while loop. Okay, so what this is going to do, when I run this program, all of the arguments that I type in on the command line are going to get stored in this array. Well, they don't really get stored in there. Pointers to them get stored there, but you know what I mean. So we consider this an array of strings. I mean, it's fiddly. It's an array of character pointers. It's called argv, but it is kind of an array of strings. So we're going to print the first one out as part of our line that says, well, actually this. and then we're going to loop through all the rest of the words, and we're going to fputs each word. So I wanted to use these new functions, right, to show you them working. So fputs takes an array and writes it's a standard output. I could have just done a printf like this, but, you know, might as well use the new functions to show them off. And then it prints a space in between them, and it loops through and it keeps going through that array until it's finished, and then prints a new line. So let's compile this. I'll call it arguments, just make sure that's fine. / arguments, COMP1511 is a UNSW course. Actually, I didn't even need that many arguments, but, you know, might as well show them. Well, actually, .arguments says there's no such thing as COMP1511 is a UNSW course. And it's like, you're not even making any sense, arguments. Mark is a lecturer. Well, actually, there's no such thing as Mark as a lecturer. so yeah. Basically, what we're showing here, rather than just like how stupid it is to have arguments on the internet, is I could put this, I could just plug this into Twitter or something like that, and just pick other people's tweets at random and just do this, and then see what kind of storm of hate I create by doing that. But anyway, this is saying it can read each of these words, and it's just showing that when we do the command line argument stuff, each of these words goes in as a separate word into this array. So each one of those is a separate pointer to the first character. So this says, so this is the first string in the array, second string, third, fourth, fifth. And so the first one, the 0, was getting printed out here, and then after no such thing as, it was looping through and taking those words one at a time. So you note that the words that get put in here are separated by spaces, and they will not take any of those spaces into the words because we had to put the spaces back in between them afterwards. So when we get the stuff in from the arguments, they go in as pure words, in a sense. No spaces, no enters or anything like that. There is a new line at the end of here where we type in, but it's going to get ignored. So it's a little bit more like the way scanf was dealing with things, where it was just ignoring all the white space and taking the core information, as opposed to if we use something like FGets, which is going to take the whole line and the extra information. When we use stuff like getchar on Wednesday, we were seeing that getchar was able to pick up spaces and enter keys. This one's a bit different. It's saying we expect each argument to be its own self-contained word, and we won't take any of the spaces around it. So we've got all the self-contained words like that, and we're able to loop through the array using I to grab those words one at a time and print them out. You don't have to print them out. You can grab those words and process them in other ways and stuff like that. What are we talking about here? No, that's right. Okay. So people are saying that Mark Chi does not exist because it's been shown in a lecture that there's no such thing as Mark Chi as a lecturer. Okay, so that's how our command line arguments work, but it's not the only way that command line arguments work. There are other things that we might give to our command line arguments. So for example, I mean, like, we're not necessarily doing this in the first assignment because there wasn't time to teach this before then. But if we wanted to, we could do things where, let's say, for example, slide had a variable sized array for how big it was going to be and how big it was going to be displayed on screen, and we did something like that where we said run slide, and then we'd give you some numbers, and the numbers would be how big that thing was going to be. The interesting thing about that is if we're reading numbers in as strings, they don't necessarily appear as numbers. Now, we looked at this slight difference on Wednesday when we said the characters for numbers do not have the same number value as their integers. So we need something that's actually going to convert strings that are numbers into integers that are numbers, because the integer stores the actual value. The string does not store the value of a number. The string stores the characters. So if I have a number like 650, the string that stores 650 says, oh, here's the ASCII value for 6, and then the next element of the array is the ASCII value for 5, the next element of the array is the ASCII value for 0, and the next element of the array is the null terminator. And nowhere in that do we get the value 650. So if we want to convert that to an integer, we need a function that's going to go back and forth between the strings and the integers. The standard library has a lot of these. There's like 8 of them. And they all do roughly the same thing, but we've picked one which has just a decent way of working. There are simpler ones, but the simpler ones don't always do everything that we need them to, so that's why we picked this one called stir to L, which is like shorthand for string to long integer. So a long integer is actually a 64-bit integer, but we're not worried too much about that. But string to integer, that I'm going to call it, this function will take in numbers, and then it will be able to convert them into, it'll take in strings, and if those strings are made up of digits, it will be able to convert them into integer values. So what it takes in is the string itself. So this is us going through the array of strings that we got from standard input and saying, okay, this is the one I want to convert. The number here is important because the number there says which numbering system are you working in. So during this course, we've actually come across 3 different numbering systems. One of them I'm pretty sure that you're quite familiar with, which is the decimal numbering system, which is the one that we use on instinct as humans. And the only reason we use it is because we happen to have 10 things on our digits. Right? There's a reason why these are called digits, and numbers are called digits as well. It's all stems from the same historical background, right? And so we use a base 10 number system because when we had nothing else to count with, we counted with these, right? So it's a really, really funny thing. Otherwise, we could have had just a completely different numbering system. But computers are all made up of like these little electrical switches on and off, so they count in 2s. So they count in their binary system. So if you put a 2 here, it would read the number from this string as if it was a binary number. And we've also seen hexadecimal. When we were working with memory locations and stuff, it was like, this is hexadecimal. Hexadecimal is just there because it makes certain bit representations of things more efficient, so there won't be wasted space in our memory addresses. So if we put a 16 in here, we would read it as if it's a hexadecimal number. So for the moment, most things that you're expecting a human to type in, you're expecting to be in base 10. So string to long that is going to convert this string into a number, we will usually be using base 10. There's also a pointer in here, and to be honest, I can't even remember exactly what that pointer does. I'd have to look it up. But most things, and I think that's a good thing to say, because a lot of people look at this and go, oh, if you're a good programmer, you understand all this stuff and you memorize it all. I really want people to necessarily be memorizing things like this, especially things that are part of standard libraries. Standard libraries are there kind of to be Googled and used. The thing you do want to remember is remember that standard libraries can do a lot of simple things for you, so often it's worth looking them up to see if there's something that helps you. But remembering the specifics of each and every single one of them is something that you can get through just doing it a lot, but it's not something that I want really people to go out of their way to try to do. I'd prefer you learn how to solve problems with code than spend all your time memorizing things. But this is a pointer, and I think you can use it to store some information that string to long gives you, but if you give it a null, then it just doesn't do anything with it, so that's fine. So most of the time we're using this, we will say, here's the string that we want to process, it's a base 10 number, and we don't worry about the pointer. So this is going to say, I will read this, and then I'll put it in here. So I actually think this isn't even in my demo code. So I'm going to do a little copy. Let's hope this works. Copy pasting from a slide is not always the best, because there's actually a lot of invisible information in those slides that may turn into invisible characters that cause my code to not work. I've seen that happen before, but hopefully this will be okay. It happens heaps with the double quotes, because you know the double quotes are on angles. They're not the same character as the double quotes that are vertical, so it can cause issues. But anyway, what do I call it? Arg convert. So talking about converting arguments. and I'll paste this in here. Demo of converting integer. No, they're not integers. Number arguments from strings to integers. This was written years ago, this piece of code, but I can't remember exactly when, so I'll credit it to myself today. I mean, at least if nothing else, this date is the most recent time that I edited it, so that's not bad to have that as the date. Okay, so I've got my two libraries here, standard input output library. I've taken the standard library so that I can get this string to L function, and this thing is going to take arguments, and it's going to count from the number one index argument. So we're not counting the program's name as the first number, and what it's going to do is it's going to total all the things that I type in on the command line and then tell me how much they add up to. So argconvert. So if I type in 2 ones, I'm expecting that the total I'm going to get from this is 2. Total is 2. Cool. So what's going on here is it's looping through all of the arguments, and it has a total that started off as 0. I don't know why there's white space there in between them, but you know, that's fine. Started off as 0, and every argument that it reads, it converts the argument string into a base 10 number and then adds that to the total. Right? So if I go here, I type in 555, I should end up with 15. Yeah, cool. So this is another thing that we can do with the command line arguments. I should put this in the lecture section as well. That sometimes we're going to convert these command line arguments into numbers for our use. Someone said, please sell Mark Chi does not exist t-shirts. That would be pretty funny. People are asking about help sessions as well. There's one thing I wanted to say about help sessions. I think from what I've heard from the tutors, not that many people have been going to help sessions. I should point out that help sessions are probably the best place to get help if your assignment isn't working that well. Because if you go into a help session with a broken assignment, you can actually just go, look, I auto-tested it, doesn't even compile. Most of the time, I think this is mostly working, your tutor can actually see the code that you've just auto-tested. So you don't even have to do your weird, awkward sharing screen or anything like that. You can go, look, I pressed auto-test 5 minutes ago, and the tutor will be like, yep, I can see that code now, let's talk through it, you know, that kind of thing. Someone was saying, one of the tutors was telling me there's been a bit of confusion because the help sessions that maths runs do not give assignment help like that, individual help like that, but ours do. So if you need it, use them. By the way, week 6 is going to get really busy. Week 6 help sessions always get really busy, especially at the end of week 6 when everyone's like, you know, panicking to get their assignment finished. So, you know, I'll say it all the time about assignments that like the earlier you start, the easier it's going to be. But, you know, I know that you're students. I've taught enough students now to know that I can keep saying that, and only some people are going to listen to me. But yeah, if you can and you do need help, go early rather than late. Someone's saying definitely I should do a Mark Chi merch and then give money to charity and stuff like that. That would be cool. I think that you may think I'm more famous than I am. Just because everyone knows who I am because I'm your lecturer, that doesn't mean that I can magically sell lots of merch. Anyway, this is the two demos here about using arguments. One is their strings, which is how they come into the program as they are, and the other one for converting them into numbers. So they're both in the live lecture, whatchamacallit, folder, which I will copy here and put it into chat. So if you can see that in chat, that's it. If you can't see it in chat, hopefully you can see the URL that I've got up here. It's always in the lecture section on the website anyway, if you need it. Okay, go back to presenting this code. So that's the code that we can do to convert numbers, if they're strings, into actual sort of programming integers that we can use as values. So we're going to go on a break now, and I just want to say, like, we are actually halfway through COMP1511 right now. So I want to say that, like, at this point of the course, it can feel a bit rough because it's been 5 weeks since the last time you had a break. I've given you an assignment, so there's a lot of work to do, and everything that we're doing in 1511 just gets harder the deeper we go in a sense. Like, it's not exactly like that. Some people reach a point where they understand stuff and they're happy with it, and it doesn't feel as hard going on, like something kind of clicks. But in general, like, it can be tough, and sometimes people are just like, I just want to make it to the end of the term. Because after we get week 5, we get a week off, and then we've only got 4 weeks left after that, 7, 8, 9, and 10. So, like, we want to just, like, hang on to the end. So I just wanted to, like, just have a little message to let everyone know that, you know, you don't have to win, and you don't have to succeed right now. There's a whole lot of pressure in the world, like, kind of pushing us to, like, be the best we can all the time. But honestly, to be the best you can all the time means you need to take the right amount of breaks, you need to take the rest, you need to have the patience to say, I will eventually be the best I can be. But the only way I'm going to survive to be the best I can be is to make sure that I'm taking care of myself and, like, thinking about where I'm going to go in the future. And if I'm just moving a little bit towards where I want to be in the future, that's enough for now. Like, I think a lot of people, like, you know, we're only 5 weeks into coding here, right? So a lot of people are like, oh, I've got to be as good as a professional programmer. It's like, no, you don't. Maybe in about 10 years' time, you start duking it out with professional programmers and, like, competing with them and stuff like that. But until then, it's more important to think that, oh, eventually I would like to be able to duke it out with professional programmers and, I don't know, win programming competitions. I never entered any programming competitions in my life, right? But, you know, the idea that, you know, we want to push everything all the time is the kind of thing that's probably going to burn people out. So, yeah. That's why I just want to say take it easy, right? And I do understand the deep irony of me giving people an assignment to do and then saying take it easy. But I actually put a note in the assignment. I don't know if anyone's looked back in the assignment recently. I put a note in the extension section just to say to people that, like, you know, that, like, in the past we used to have just the whole assignment. So the core in the extension was just the assignment. And people would try to, like, kill themselves to get the final stages finished. And so that's why I've separated those things to be like, you don't really need these final stages. Yes, okay, fine, they're worth marks. And so some people think that you need to get 100% in everything. But I should point out that I never got 100% in anything at university. And then I worked as a professional software engineer with, like, you know, good salary, good job for, like, over a decade, and then ended up teaching and all this kind of stuff. You don't need 100%. And so that's why I say to people, the core is what you need, and the extension is if you want it. I think that that's a good way of thinking about things. And I put in that note that, like, you know, if you get a credit in COMP1511, then you're fully capable of continuing your degree and should be happy with it. And you'll be fine in computer science, that kind of thing. So a lot of people think that they need to get 100% in everything. I guess it's a bit of a warning, because when you come out of high school, you try to get 100% in every assessment, right? And I know the ATAR cutoff for computer science is in the 90s, so everyone's used to getting really high marks and everything, but the average mark for 1511 is about 65 to 70 or so, and that's where it should be. And universities are going to grade you at that scale, not at the high school scale. So just be careful about trying to win everything when the competition has now changed dramatically. It's not a competition either. Anyway, I'm going to stop talking about that there, because I could just keep going about that for ages. So let's go on a break now. It's 5:01. We'll come back at 5:06. and then we'll do a demo using strings and command line arguments and stuff like that, and we'll do some coding. All right, back soon. Hello, I'm back. Everyone's gonna be really, really disappointed because, like, during break when nothing was on, Chicken just came and walked in here and started talking to me and stuff like that, and like no one got to see it. She like knows that I'm on break. I like to call her Chickapoo sometimes because like she's my little Pokemon, so she's like Chickapoo, like not Pikachu, but anyway. A lot of people talking about like different marks and stuff like that, and I apologize that I kind of triggered that conversation. A passing mark in COMP1511 means that you've understood everything that I think people need to understand out of the course, and everything above that is like, you know, like it's kind of like showing off. A credit's very good. A credit means that you'll be fine in like you won't have a great deal of trouble in harder courses that come after COMP1511. And then if you're getting a distinction or a high distinction, then you're kind of like, well, good. You have a great deal of understanding in everything in the course. You've probably got enough understanding to be able to teach it. You know, like I've hired people to teach the course who got marks around sort of 80 and above in a sense. So that means I trust that you know it so well that you could pass it on. It's not just that you can do it, you can actually teach it as well. So that's kind of like where it's at. So like there's what's necessary, and then there's what's like fun or showing off and stuff like that. And so it's kind of like, I would say your necessary mark if you're in like a computing major and you want to be a programming major in computing, in a sense. Like, because when you think about it, like in your average computing company where a whole bunch of people have computing degrees, only about 40% of those people are coding, you know. And there's plenty of like full-on careers in computer science where people may have had computing degrees initially, but the amount or difficulty of coding they do is not very high. So, for example, this dude, like, I have been working as a computing professional for the past 5 years, and the complexity of code I've written has basically been starter code, stub code in order to get other people to write code, you know. So it's interesting how that works. Okay, so let's move on to what we're going to do as a demo today in the second half of the lecture. So this is the whoa, we're halfway there part of COMP1511. So those of you who don't know what that song is, and I don't know how you couldn't know because I'm such a good singer, is this is Bon Jovi's Living on a Prayer, which is probably the both the best and worst karaoke song ever written. So at this halfway point, I thought we'd do something that is going to use a bit of everything that we've done in COMP1511 so far. It's not actually going to use much maths or numbers, but it's still going to use, like, you know, if statements, while loops, arrays, and stuff like that. And it's going to be using arrays of characters now that we've got characters. So it's a program that helps you do rhyming. Oh no. Okay, people have noticed. People have noticed me singing. Okay, so what we're going to do is do something that helps us to write rhyming lyrics. So it's like a song. It's a song helper program. So it's going to read in a string from the command line, and then it's going to read another string from the user, and it's going to say, all right, do these things rhyme or not? So we've got like the basic word that goes in on the command line, and then we can type in other words and go, oh, does this rhyme with that word? And we're going to get the computer to look at these and say, how well do these two rhyme? And because we've only got 60 minus 10 minutes, 50 minutes to do that, I'm just looking at the clock over there. We're not going to do this very well, but we're still going to see a lot of programming concepts that get us doing this. So we're going to check the string that we input. So we're assuming that the command line thing is a whole line, and we're checking multiple different words that might rhyme with that particular line. So we're going to check the last word in the command line string against the input string, and we're going to see how similar those are. And then if those are similar, then we're going to say that they might rhyme. Now, as we do this, you're going to notice that the way that I'm checking whether these things rhyme is not that amazing, but it'll still tell us something about what's going on. So we're going to start simple, right? We're going to start really simple. We're going to read in a string from the command line. Then we, given all those words that we've taken from the command line, we're just going to read a single character from our standard input and see whether it is in that string or not. So the first thing we're testing is just for character matching, and then we'll go on further and we'll compare whether a word is like another word or not. So first thing that we're going to want to do is, if we are saying that we're going to take some information from the command line, we should do that. And then we can have a check to make sure that something has been typed in the command line. So if argc is less than or equal to 1, that means only the program name or less. I mean, less isn't technically possible, but I like to check for those things anyway. If the argc is below that, then we don't get, we don't have anything to rhyme with, and so we would kind of end the program there. So I'm going to do that in an if-else way. let's hop across to our code and start working on that. So I don't need these two anymore, so I'll start a new gedit window. I'll call it rhymer. I don't know if that's grammatically correct, a word, but I'm going to go for it anyway. Okay. A rhyming helper program. Takes a line from a song on the command line. Helps the user decide whether words they input will rhyme with that line. A demo of characters, strings, and command line input. Alright, that should be enough information for people to use this. Right, so what do we need for this? We're going to need our standard input-output library, where, you know, we're talking about... Oh, the command line doesn't need that, but we're talking about user inputting words, so we're definitely needing standard input-output. I don't know if we're going to need the standard library. Let me just not... I won't put it in until we start to use it. Like, often, on instinct, I will just do the standard library as well, but actually now that I've typed it in, I'm going to leave it there because I think that there's going to be something that I'll use. Okay. Now we are at a crossroads with our int main, where previously we would have just typed in void and then started working. But now we know that we're taking command line input, so I'm going to go back to my slides because, like, you know, the first time you do this, you're always going to be like, what was that again? Arg what? Right? So we go int argc. The first thing is the integer, which is the argument count. And then the second thing is the complicated array of character pointers, or we'll think of it as an array of strings, which is argv. So I'll put those two things in. Int argc, and it's a character pointer array called argv. Alright, so now that I've got those there, I know that my program, when I take in input, is going to have access to those things. So first thing I'm going to do is check whether there was command line input or not. And I'm actually going to end up doing this where the entire program is probably going to be in this else statement. Actually, I don't think I necessarily need this. I could actually do it where I could just put... I don't need an if-else. So if my argc is greater than 1, it means that there are other words on the command line. If my argc was 1 or less, then there would be no words on the command line, but this means that there are, which means my entire program is going to be inside this if statement. And if this if statement is false, I'm going to just jump to the end and finish. I can put a return 0 in here as well. Sometimes it's nice to have the word there to remind me of what's going on. So basically, valid program here, invalid program just jumps to the finish. So just going to put a comment in there saying that if we get past this open bracket and we're inside this if statement, then there are command line arguments. So if there are command line arguments, actually I still think maybe I should have something else. There were no command line arguments. I've already diverged from what I had done in the on the slides, so I apologize for that. But you know, this is live coding, so I'm always going to make decisions on the fly. So there were no command line arguments. I might say something about that. There was nothing on the command line to rhyme with, and then the program ends there. But assuming that there is something to rhyme with, then we can start thinking about things. See what people are talking about. Oh, Rani's answering lots of questions there, so I'm gonna trust that Rani has got this covered there for the moment. Okay, so if we have argc greater than 1, that means that we do have some command line arguments, so that's this kind of thing here. And so what we might do then is, if there was command line arguments, let's start with the simple program. We're just going to get char just once and go, all right, let's get a character from standard input, check to make sure that there actually was a character that we could use, and then we'll see if that character was in the, I'm going to use the final word of the rhyming line, because we want to use the final word to be like, because we're going to rhyme the final word with the other word that we're going to put in. But for the moment, we're going to just do a single character to make it easier for us to understand what we're doing. Okay, so things that we are doing in here. I'm going to give myself some space so that you can see what I'm working on. When I'm reading in a single character, I will read in an integer in case I get an EOF. So what I'm actually going to do, this is a cool trick, and I think we've done this kind of trick before. I think I did this with the dice checker at the very beginning, where I made it a -1 so that we would know if it had never been initialized properly. So what I'm actually going to say is the input character is a non-character. This is the only value that I'm sure that my computer, my program knows is not a character. If it's EOF, it's not a character. If it's anything else, if I gave it a 0, that would actually be an ASCII code. So it's better as EOF. And also this is a define that we kind of start to recognize. So we know that this is like saying it's a non-character. So what I'm saying is if I initialize it as a non-character, then if I do something wrong later and I forget to give it a value, then this thing is just kind of going to ring alarm bells for us. If I did something like this, input character is A, and so I initialize it as a basic letter that I think I might use. Later on, if I'm not taking input properly, I'm not going to see that there's a problem because A will look correct. So I don't want it to be nice. Like when I want my mistakes to come through, I want them to come through big and loud and clear. So I'll start it off as EOF. And then, what was I doing here? Yeah, then I'll do my get char. So my input character is equal to get char. So this is saying grab a letter from the standard input, put it into input character. So now that I've done this, I'm expecting that a correct running of get char will have changed input character from EOF to something else. So now I can say, was the input valid? If input char is not equal to EOF, that means that get char had done something valid. We received valid input, and now I can do something with it. So that's like a simple test there. And then what I might do now is I'm going to check if a letter is in a string. And if I'm going to check if a letter is in a string, that's like a kind of a generic idea of doing something. So I know that checking for a letter in a string feels like something that could be self-contained. It feels like something that doesn't have to be in my main, but something I might use more than once. And when you start thinking like that about things, you go, okay, that could be a function. If I'm going to check whether the letter is in a string, and I think that in this program, I may want to do that more than once because I'm going to check for all the letters in a word and see if they're in another word. Perfect time to put this in another function. So I'm going to write this check letter function. So integer, because I know I'm going to want to get some information back. And I'll think about what that information is in a second. And I'm going to take in a single letter. Single letters I'm expecting to be integers. I know it's weird, right? Because I told you about the character variable type, but most of the time when we have a single letter, it's because we've done something like this and we needed to use EOF that it comes in as an integer. So we're going to just kind of lean in on that and still use them as integers. But when we're using arrays of characters, we're definitely expecting them to be arrays. I could do this where it's an array, or I could call it a pointer to the first letter of the string, and then say that I'm just going to go walking through that string anyway. So I could say it's a character pointer word, or I could say it's a character array word. Functionally, these will both work the same way for me. I might leave it as the square brackets because it reads better to us as humans as in the square brackets, because it reminds us that it's an array of characters and it's a string. If I say this, which actually heaps of the C standard library does, this could be implied to mean a single letter, like a pointer to a single letter. So, you know, I'm judging the people who wrote the standard library. So this is the way I like to do it, because I think that this will give us some slightly better information. Okay, so we've got our function down here. If we're going to write a function, we do need to explain what it is. Looks for letter in word. Returns. You know what I'm going to do? I wonder. I think I was actually doing this already, right? Yeah. Okay, this is cool. Returns the index. Returns the first index where it found letter. Returns the index of the null dominator if it did not find the letter. I wonder if that's the same thing as I did here. Yeah, because we return... Yes, it is the same thing. Okay, good. Thinking the same way. So what we're going to get is, if it finds it, it'll give us where it is. So this is me kind of planning for a potential future where I might want to know where it is in the word. So it'll tell us where it was, and if it can't find it, it'll go, I looped all the way through the list and my index ended up off the end of the word. So here you'll have some information that tells you we didn't find it. So in order to do this, I know that I'm going to loop through the word, and when I find something, I'm just going to return the first index. So I will start with an index, and I'm going to call it found index. So it's going to actually tell us where things are. I wonder if I... Oh no, I did it differently, didn't I? -1. Ooh, -1 might be better. Okay, I'm gonna go with past mark here, because -1 is really, really clear to not be a possible index in that array. So it returns -1 if it didn't find the letter. So this is found index starts at -1, and then I loop through looking for it. So I'll go I equals 0. I'll set up just this really bog standard while loop here. Sorry, scroll down a bit so you can see my code. Should be able to see my code fine there, right? Ooh, someone tagged. Rani tagged me. Might direct this to Mark. Okay, Gorb. This question. Can someone explain why char* word does not represent a pointer to a character? Well, it actually does. I think the weirdness is the arrays are the address of the first letter in the array, or the first element of the array. And a pointer to the first element of the array is going to store exactly the same information as the variable name for the array. So if I create an array, let's just say this is an array, right? Word, and I pass the variable name word to something else, it's going to give me the memory address of the first element of word, which is exactly the same as me saying I will create a pointer to word 0. And then what is the address of the pointer to word 0? It's exactly the same as the address stored in word. So it's not that the character pointer to word can't mean the first letter. It can mean the first letter, but it can also mean this is the first letter, and also if you continue onwards, you'll be able to see other parts of this array. So it's an awkward subtlety in a sense that because the array as a variable is the address of the start of the array. That's also the address of the first element in the array. So a pointer to the first element and the array variable are actually the same memory address. So I think that's, hopefully that helps, because it's weird. It's not that there's a problem with what you were thinking, which is that can a pointer to the first letter just mean the first letter? It's just that the pointer is the address of the start of the array, and if you're looking at the first letter or you're looking at the whole array, you'll get the same address. So yeah, it's fiddly because of the way arrays are set up more than anything else. Okay, so we're looping through this word, and the interesting thing is we're looping through a word we don't know how long it is, because we could get given any word. This is us working with variables with like I shouldn't use the word variable, a word that can have a different number of letters, a variable number of letters, right? So what we're going to do is we're going to keep looping until the current letter that we're looking at is the null terminator. So I'm going to say keep looping, and if you haven't hit a null terminator, then process it like a letter. If you have hit a null terminator, then you've hit the end of the word and you should stop looping. So we go, if it's not the null terminator, it means it is a letter. So let's check if the letter we're looking for has the same value as the letter we're currently looking at in the word, which is word I. Interesting thing here is we can compare integers with characters because they're both numerical values. There are things that we can't do with them. If you start trying to add them together and stuff like that, I mean, it's technically possible. It is technically possible, but you have to be careful about which is it. Is it a character or an integer? Because one of them stores more information than the other. Most of the time it's okay, but if you go into negative numbers in a character variable, it causes issues. Again, this is one of the reasons why heaps of the time if we ever are doing any arithmetic with letters, which is always a weird thing to do for starters, our individual characters are usually integers just in case we need to push them negative for whatever reason. Yeah. So we go in here, and if the letters matched, then found index is going to be equal to I. So if we found a letter in the word, found index is equal to I. Interesting thing about this is at this point in time, we'd probably want to end the loop here. So if I've already found a letter in the loop, I just wanted to return the first index where I found the letter. So if I found it somewhere, I don't need to keep looping. So what I could do here to make this while loop end if I found something is I can do this thing as well. So I can say, if you haven't found the null terminator and also found index is still equal to -1, then we need to keep looking, right? So we now have two conditions in our while loop here. One that says, if you haven't gotten to the end and you haven't already found something, keep going until either you find something or you just keep going and you hit the end of the word. So now, when I finish this while loop may or may not go all the way through the word. So it could go all the way through the word if it doesn't find something. If it does find something, it will stop early, but that's fine. It's not that big a deal because the information we wanted is in found index. So what I'm going to be returning here is, if the while loop stopped on this condition, so it got to the end of the word, I'll be returning -1 because it will still be -1. If it stopped early because found index changed, found index will then be where in that word we found it. Yeah. So this is our way of saying that we're actually like entering into this tiny little bit of sort of efficiency in a sense where I'm going to stop my while loop early if I think it needs to stop early. Oh, ZG says he's behind you. I'm not sure what it is I've done here. That's okay. If I can't see the problem, I will use my problem solving techniques to find the problem. So I'm going to put some code in here that actually checks that. So if we received a valid input, then we will run check letter. There's a lot of people where it's behind me, so let's have a quick look in here and make sure. Oh yeah. Okay. It's always the simple things, isn't it? Hands up everyone who's been programming in Python in recent times and leaves all the semicolons off their C code. Okay, everyone can stop now. It's alright. Yes. Line 42, very significant number. Okay, so we're going to check letter, and we're going to check for the thing that we just read as inputs, the input character that we have made sure is not an EOF, so is a valid character. So we're going to check input character against... Thanks, CG. Okay, input character. That was just an excuse by way of that Python thing. I haven't actually been coding Python recently, but I'm going to use it as my excuse. Okay, so checking the input character, and we're going to check that against the last word in my argv. So argv, and the index is going to be... So argc is the number of things. If it's the number of things, then argc is not a valid index, but one less than it is the final word. So this is going to check for, did this input character exist in the final word? And then for us to understand whether this is working or not, I could say found a character at index number in I'm gonna combine my print statements in a sense like this. So I'm gonna just say in and a space there, and then I'm going to do fputs. So you can actually jump between these things, you know. I'm not saying you have to go all the way one way or another, but I can say fputs argv argc minus 1 in standard output. So because I didn't put a new line there, this word in this fputs is just going to go right next to the other word like that. So the character that I was looking for was input char, and the index I found it at was, I stored the result of check letter in found there, and then I fputs that. Oh, I'm going to use all of the different things. I'm going to put char. There you go. If I'm going to demo all the functions I taught you, I might as well use them all at once. Okay, this is like the most complicated print function ever. I could have done this with less effort than this, but I just want to show you all the different functions working, so it's like totally worth it. So, read in a character. If the character is correct, we check that character against the final word, and then we let ourselves know at what index we found it. So this should be a decent test of... Alright, gedit stopped for a second. That's fine. I'm just going to let it deal with what's going... Oh no. Come on, VLab. It's interesting that VLab's doing this at the moment where it's not lagging. Because my input is fine, but it's like the processor has got me on a queue to do things. I should talk to our systems people about this. Let them know that something is up. Okay. So I'm going to compile Rhymer. Now, I've stopped talking about it, but you can see me using it all the time. I'm tab completing things, I'm using my up and down and stuff. So those of you who have or haven't been spending a lot of time in terminals from now on, know that there's a lot of shorthand that can get you through this stuff pretty quickly. Okay, so I'm going to compile this. It compiled fine, so obviously everything must work, right? There's not going to be any problems here. We'll see about that. Okay. So Rhymer, and I'm going to put in a line from a song. What is it? Is his name Tommy? Yeah, it's Tommy. Does anyone know what I'm doing? That's the first line of the song, Living on a Prayer. So I'm going for it here. And I'm just like, I'm leaning in on the very, very funny and quite silly song that, hey, at least I'm not rickrolling you this time. Okay, so let's see if we're looking for a letter inside the word docs. So let's look for the letter C. Ooh, found C at index 2 in docs. Index 2, this is index 0, 1, 2. So I think that to a certain extent, my my check letter is working, but let's check it again with a letter that's not in that word. Found X at -1. Okay, so the text is not entirely correct, but we can read into it with a -1 that's kind of working. Okay, so I think my check letter function is working reasonably well. So that's I'm never gonna say my function is working. You know, I've written enough code in my life to know that there's definitely a way to break this. I just haven't found it yet. Okay, so now we can check for a letter inside a word, and we've got an idea of where it is in the word, which is nice. Whether or not we're going to use that, we'll see how we go. So, talking about the last word in argv, I think I've already spoken about what's in this slide. So, if we're going to test a whole word instead of just individual letters, because we want to see whether a word matches another word to see if they rhyme. We could, if we wanted to, we could loop getchar and get individual characters, but what we're going to do is use FGets. So I've talked about FGets a second ago, earlier in the lecture, but we can use FGets to get an entire line from standard input, which should be enough to get us the word that we want to rhyme with. So let's do this thing here where we create an input line, and I'm going to hash define this as a maximum length as my kind of theoretical maximum for a word length. And I'm going to ask my user to input something, and then we're going to FGets it. So what we're going to do is I will comment this code for working with an individual character, and we're not going to use this anymore, but it was good to have this running at least once to see whether it works. So what I'm going to do is I'm going to comment out this entire body of code here, but keep it there because it is something that we might want to keep for reference. We may want to reuse bits of it and stuff like that. But in the meantime, I'm going to create a word that I can use. I'm going to ballpark it here and say the maximum word that I'm expecting to rhyme with is going to be no larger than 100 letters. Because how long is supercalifragilisticexpialidocious? Because I think that would be the longest word I'd be expected to rhyme. And I think that still fits within 100 characters, so I'll probably be okay. So I'm going to make an input word. I was thinking about what to name it, and then I called it the input word, so I figured that's a good name for it. What did I call it there? Input line. Yeah, close enough. And it's going to be of max length just in case it needs it, and then I'm going to do my FGets to get input. But what I might do is tell my user what kind of input I'm expecting. Please enter a word to rhyme, and then I will spell that correctly. I will FGets that word. So using library functions, I might need to look them up to be sure of exactly what I'm doing. For me, I know I can look up my slides, and I know that the first thing is an array that I'm going to put it into. So it's a character array that I'm going to put the information into. The second thing is how big that array is. So I know that if my user gives me a line that's too big, I'm not going to store it all. I'm going to store not actually 100 here. It's going to be 99 letters and a null terminator, because FGets is always going to give me a well-formed string. It's not going to give me an array of characters that doesn't terminate. And where am I getting it from? Standard input. Standard input is the typed in stream. So I called it input word in this demo. That's fine. Max length, I think, was the same. Hash define. Standard input is a C thing. So I know that this will then read a word from my standard input. And so I've got the word I'm trying to rhyme with, which is going to be, I think I heard it here, argv at the index argc -1, so the last word in that line. And I have this word that I've just now typed in, and I want to see how similar these two words are. So I could do that in a kind of simplistic way, and I've said it here. This is not a great test for rhyming, but if I want to, I can have two words, and what I can do is I can loop through one word and check if its letters exist in the other word. And if all of its letters exist in the other word, then I'm kind of going to go, yeah, maybe. Like, maybe I can say they rhyme. I mean, like, as I say here, not a great test for rhyming, but I will talk about a better test for rhyming that we don't really have time to do. But I have a function that's going to check for a letter in another word. So if I'm going to check for all the letters from one word for another, I will use that function. So what we're going to do is write a function that says it's going to give us back an integer because it's going to be telling us how well these two words match. It's going to be basically how much of one word it found in the other. So we're going to have one word. I'll call that one word 1. And the other one word 2. And let's write this function. So previously, when I wrote the other function, I was thinking, oh, I'm going to use this multiple times. So I made this function to not reuse code. This function here is nearly being written. I'm just going to put some enters here. So this is not working code or anything. This is just so that you can see it more clearly while I'm lecturing. This function I've written because I know that it's a complicated piece of code that's going to have to do a lot of stuff. But from the human perspective of reading it in the main, the only thing the human cares about is whether these two words match in some way or another. So this is me saying, take complicated code and put it somewhere else so people don't have to know about it. So check how many letters from word 1 appear somewhere in word 2. Return how many matches were found. So, if I'm going to return how many matches were found, I know that found matches? Found letters. Both of those variable names would be fine. So I kind of, this is another way that I might set up a function. This function works. It will compile and it will run. So you know how I do that sometimes? I just build it safe first and then I build it to work later. So this function, if I were to run it now, it would tell me that no words ever matched any other words, which is incorrect, but at least it will compile and run. So sometimes I'll do that and I'll go, okay, in order for this to give a more accurate answer, it needs to be able to do some work. So I think what we're going to do is we're going to loop through word 1. And for each letter in word 1, we're going to use our individual check letter from the letters in word 1 to word 2. So let's set up a loop. I need to know where this ends. So I could end this. How was I doing it in that? Oh, I was being tricky here. Okay. I'm gonna replicate the trick that I did there. I'm gonna start at the end of the word and go backwards. There'll be a reason for that later. So if I start from the end of the word and go backwards, other than just it's cool sometimes to reverse your loops, just when you're teaching people, so you show them that loops don't always start at 0 and go forwards. So if I start at the end of the word and go backwards instead, so I'm going to go I minus minus, and I'm going to start at I being equal to the length of word 1 minus 1. So sometimes I also like to write in English and go, okay, how am I going to do this? Length of word 1 minus 1. How do I get the length of word 1? I could write another function that does it. Or, where is it? I could go here. Int strlen, character pointer, which is a string. Return the length of the string, not including the null terminator. Handy. Why don't we use that? Okay, where are we up to? Yep, here. And I used it here as well. So, strlen will give me the length of word 1. Strlen of word 1. This is going to give me the length of word 1, and minus 1, this will give me the final letter. So I will start pointing at the final letter. Not pointing at, it's not a pointer. It will start as the index of the final letter. If I want to use strlen belongs to a library, it belongs to the string library, which I have not included, so currently my code won't be able to use it. Actually, let's just, I'll just show you something. I don't know if that while loop will compile. Doesn't matter. Let's compile. Ooh, implicitly declaring library function strlen with type unsigned long, that's the character pointer here. You are calling the function strlen, but DCC does not recognize strlen as a function because you have forgotten to include string.h. Thank you very much. DCC explanations are really good. It's like, are you sure? This is the thing we think may have gone wrong. So, can't use the library function without knowing about the library. Include string.h, and now we will try to compile. Oh wait, there's still an error in the while loop. I thought that might not compile. Yeah, you can't have an empty test in a while loop. But now I can say that if I'm starting at the end of the word and going backwards, I can say I has to be greater than or equal to 0. Because if we're starting at size, so let's say the word hello will start at the index 4, and it will go 4, 3, 2, 1, 0, and it will stop after it gets to -1. Okay, so going through the letters of word 1, checking where they appear in word 2, I realize now that maybe I didn't want the first index where I found the letter. Maybe I want the last index where I found the letter. Because if I'm going from the back and finding the last index, I will be seeing if these words match up exactly. I might change that. Actually, no, let's just change that. That's actually really easy to change, because all I need to do is make this not finish early. If it doesn't finish early, then I will return the last index where I found the letter. So, interesting. Yeah, I don't really need to change that much. So I've actually just flipped a few things around here, so that check letter now is going to find the last time I found a letter in something, and I'm checking from the back of the words. I'm actually kind of checking backwards through my words. I could also, as someone said there, I could have iterated this one backwards as well. And if actually that would have taken less work. But too late now. We've written the code. I've only got 10 minutes left, so I'm not going to go back and rewrite code. We're going to write new code. So we're looping backwards through word 1. And so for each letter in word 1, we are going to check letter for word 1 I. So that's the current letter we're looking at. Check letter is the letter against the other word, and the other word is word 2. This is going to give us an integer back. So I'm actually going to use the same kind of names that I've used for things in other places. So the found index is actually going to be the same name as the thing that it was giving out. These things don't know that each other exists, so it's not the same variable. They're within their own curly bracket sets, so they don't know. But it's funny, the value is getting passed from a variable of the same name there as the same name here, even though they're separate variables. Okay, so this tells me where it found something in that other word. And then I'm going to say that if found index So this is returning -1 if it didn't find something, or 0 or higher if it did find something. So if found index is greater than or equal to 0, then we found the letter. So if found x is greater than or equal to 0, we found the letter, which means that the number of found letters should go up by 1. And then we return found letter. So this function now is going to be able to tell us that how many of the letters in word 1 also existed in word 2. So if we come back up here and we say, we have gotten a word as input, and we know that we had a way of accessing the other word. Now let's check if they rhyme. Int, I'm going to call it a rhyme score, because it's not really, but you know, a rhyme score is going to be equal to check words of input word against argv argc minus 1. Right, just making sure that no one's saying he's behind you. And then I'm going to print out some information. Rhyming score is out of this. So what I'm doing here is saying this is how many letters matched out of the length of the word. So rhyming score is rhyme score out of, and we'll just use the length, sterlen of the input word. Okay. Just going to drop this down here. Let's try this, because I think we're at a point now where we could say, all right, do these words rhyme or not? Well, got to compile it first and see. Format specifies type int, but argument has the type unsigned long. Let's see if the format codes are correct. Integer. I think this is just because sterlen gives you a very specific integer type, but I think these are going to work because I think they're both different types of integers, so hopefully the number will still come out the same. We can test it and see. If it doesn't work exactly, then we'll make some changes. But I'm pretty sure sterlen is going to be able to be read as an integer. Wait, it's not he's down on his luck. Union's been on strike. He's down on his luck. I think that's the next. That's the next. The next line of the song. Okay, please enter a word to rhyme. Need to rhyme with luck. Oh, that's not even the last line of the song, isn't it? All right, I'm going to type in the actual word, which is the last line of the song, which is tough. And it'll be like, oh, how well does luck and tough rhyme? And they don't really rhyme that well, but we'll see. Rhyming score was 1 out of 6. So 1 is the U that matches, and there are 5 letters here, but this says 6. I wonder what's going on there. I think a lot of people are probably going to know what's going on here. Because I have done some stuff with FGets here to take input, and we looked at this on Wednesday. But let's have a look. Okay, so sterlen, I've talked about this. Are we sure our program is working? So we can look for a few things, check some inputs and stuff like that. If we want to see what that extra letter is, maybe I need some printfs in check letter to say what's going on. So I can do some testing there. So I'm just going to copy this stuff because I'm running out of time. So I'm going to go quickly here. And so if I want to, I can put into check letter. in the loop. Oh, actually, don't need in the loop, because check letter is just one letter in the word. Checking for this letter in this word. I'll save this, compile this, and run it again. Yep, same warning, but it seemed to be okay. So I'm going to run it with the same words, just because we know that there's an issue here with the number of letters and number of words. And it's like, please enter a word to rhyme tough. Checking for this in word luck. Oh, that's interesting. Oh, I should have put more spaces in there. It's alright. But anyway, FGUOT. So that's going backwards through the word tough. That's fine. But this is the interesting one. We've got an enter there. We've got a new line there. So because we used FGets to grab our word, FGets is going to grab all the characters that we typed in, and so it's got a new line. So what we might want to do then is get rid of the new line that's there. So if we have these little issues like this, we're reading new lines as characters, and we want to remove that from our FGets result, we can definitely do that. So what we do is we have a look at the last letter that was input in that line. And if that last letter happens to be a new line, we can actually replace that letter with a null terminator, and that's going to like shorten the string by 1. So the new line that's on the end gets replaced by a null terminator, which kind of moves the finish of the string 1 space inwards. So let's do that here, where we've done our FGets, and before we're doing our rhyming check, we can remove the new line from input word if it is there. So what I'm looking at is the last letter in input word. So int, I'm going to call it last indexed so that we can understand that this is the index of the last letter, is the length of input word -1. So length is always going to be off the end of it. Length is going to be the index of the null terminator, and we go back 1 in, then we can check, is that last index of input word last index is equal to a new line. If it was, we're going to replace it. So we'll replace this. If it was that, we replace it with a null terminator instead. You might be asking if this is a problem. If we have more than one null terminator, is this a problem? It's not a problem, because everything that uses a string will stop processing anything after it hits a null terminator. So I could have hundreds of null terminators, and that would be fine. In fact, if I wanted to, here, input word, I could actually initialize this as all zeros, and then we'd find out that the null terminator is actually 0. And then this would mean that no matter what I put in there, it would hit the null terminators at some point and stop. I don't necessarily do that because I can't trust that the null terminator is always going to be a 0. So I just go, no, you've got to do it explicitly. And this is saying if the last thing was a new line, replace it with that. I say if because we're not guaranteed that FGets is going to make the last letter a new line. Okay, let's save this. I'm running out of time, so I need to go quickly. And we run this same thing again, and we do tough. And this time, we've still got our printf statements in there, but that's okay, because this time, rhyming score is 1 out of 5. So, 1 out of the 5 letters here matched the last word here, so that's my rhyming score. If I do something like, let's say, duck rhymes with luck, and we know that does, I got a higher rhyming score. 3 out of 5, 3 out of 4. It's not exactly correct or anything, right? Because that's just counting things, but it still gives us some useful information. So what I'm going to do, I'll get rid of these printfs that we don't need anymore. And I'll save that. That'll be the final place that we're at in that. And so this is where we're at the end of the lecture. We have a simple rhyming helper, which is able to work with characters and strings. So what it's done is it's taken in command line input. So it knows that it can use those command line input as strings. It takes in a single string, uses some library stuff and things, and is able to loop using the null terminator and things. And we're using functions. So a lot of this stuff that we're piling on like that. Challenge, if anyone wants, like you may have noticed I did this on purpose. That rhyming amount looped backwards may be a challenge. As I say, bonus marks doesn't score you actual marks, but a challenge is, can you make rhyming amount do things better? So can it match things based on their indexes and whether they match up correctly, and then say these two words definitely rhyme because their last 3 letters are the same, or their last 5 letters are the same, or something like that, and then you might get a better rhyming score as well. So I've got an example there of that. So I'm just leaving that out there in case anyone feels like doing this. Although there's another challenge that does get you real marks, which is working on your assignment instead. So up to you, you can decide. So I'll wrap it up there. Oh, someone said they liked the lecture, except Chicken didn't appear in the lecture. I actually don't know where she is right now. But, I apologize, Chicken didn't appear today. So I have to wrap it up there. Sorry, I'm over time. So I will go into break mode, and I'll come back and answer any questions anyone has about the code and go back over things as well. All right. See you. I had to go and collect her. She was just meowing at me from the corridor. So I had to go and pick her up because she was meowing. I think she's like trying to get me to go to the other room. And so she was like meowing at me and then walking away, and then meowing at me and walking away. So I had to go and like grab her and pick her up and bring her back. So she's here now. So can I have my 10 out of 10 now? But she doesn't really want to be here. She was like seriously, she was standing outside the room meowing at me, and when I walked up to her, she would just walk away a little bit. So she's trying to lure me to another part of the house because I think that she just wants to play in a different part of the house. Oh, I got my 10 out of 10 now. Oh, some people are rating me 11 and 12 out of 10, which is very good. Obviously me, it's not Chicken. It must be my lecturing is that good. Okay, so back to the code. I know the microphone's not good enough to pick this up, but she's actually purring now because she's actually quite happy. If I put her on my lap, she's always happy because it's warm, and she's starting to be really really extra affectionate as it gets colder, because like she doesn't really love me, she just loves warmth. Someone wants to do like a Teams Zoom meeting where they get to speak to Chicken. I should bring Chicken when I turn up to tutorials every now and then. So like I dropped into one of the online tutorials yesterday, but Chicken wasn't actually there. Okay, so now that I have disrupted my own teaching with my pet, does anyone have any questions about the code that we're working on today? And I can talk through and clarify things if people need. Lorenzo's asking about, can I clarify what argv means? Now this is like, right, oh, sorry, you can't even see me anymore. Actually, you don't need to see me. I'll just get into camera so that you can see Chicken. It's interesting, right? Because argv like this. So let's break this down into its parts. Actually, let me just. Oops. No, you didn't want to do that. So up until this point, we've not declared a variable this complicated, because we've done arrays and we go, okay, arrays contain something, and we've done pointers and we go, okay, pointers point at something, and so this is like now upping the ante on what we're doing. So the easiest way to think about this is to separate this into a type of thing that goes into an array. So I'm going to do this and say character pointer. And then I'm going to do this and say array. So what we have is an array stores multiple of a variable. I'll just change pointers so that you can see what I'm saying. So multiple of a variable. A pointer is a variable. A pointer is something that aims at another variable type. So we don't worry too much about the character here. What it is it's a character pointer, multiple character pointers being stored. And a character pointer is like the address of a character. So it being a... Oh, someone said you can hear the purring? I'm moving her right up to the microphone. I don't know if you can hear that or not. Anyway, so what we have is an array of character pointers. And you can think of that in different ways. So if I have, let's just do a few of them, an array here, and then like over here we've got an array which is like I'll just do the word and /0. Then this, if this is argv, this could be an array of pointers, which means each one of these could point at a character array. So let's say this third one is and. So this pointer, I'm just going to cut through the text there, goes up there to and. Okay. Chicken's moved a little, so that's fine. She's going to sit on my mouse pad because it's nice and soft. So argv contains these pointers. These pointers give us access to these strings. So it's very similar to this string might have its own name. If it was its own function, it would have its own. If it was its own variable, it would have a name, and it would also be an address of the first letter in this. So this is an address of the first letter in this, and that's how we access the elements of argv as if they're strings. So an array of character pointers can work exactly the same way as an array of strings. And Lorenzo's saying, yeah, the strings aren't necessarily all one after the other. Yeah, it's not. So the pointers are all one after each other, but these strings can be anywhere else in memory. And especially they're likely to be in separate places in memory because we don't know how big each of them is going to be. If we don't know how big each of them is going to be, we can't put them all next to each other in memory like this. So your argv stuff is going to be, I mean, it's likely to be really close to each other because they're created when the program starts. So the program has a sort of an idea of where they're going to be, but not that exact, right? Because like your memory layout is going to happen when your program starts running. And I don't know if that's before or after the argvs get processed. So those arguments may be in separate pieces of memory, so there could be another one over here, and it could be pointed at by this one. So if this is my memory space, you know, they could be scattered. They're not going to be that scattered. They're going to be reasonably organized, but there's no guarantee they're going to be together. Okay, Sarah is saying, can you explain int found index equals check letter word I2? Okay, so we are in here, I think it was. int found index equals this. So we have two words. So each of these is an array of characters. What we're doing now is we're looping through word 1. So I'm looping backwards here just to, kind of show you reverse looping, but also lead people towards a potential challenge that they could do with this. But you can just think of word 1i being one of the letters in word 1. So if it's just one of the letters in word 1, then we can put it into a function with an integer, because each letter in word 1 is going to be a character, and a character is a number, which is the ASCII code of a letter. So long as we understand that we can put a character into an integer function, because they're both numerical values for things, then we know that that is going to work. But we just have to remember that, is this a number which is like a quantity value, or is it a number that is a code for a letter? And we have to remember to not get mixed up in those if we start passing characters and integers around between functions. We've got to make sure that we're using the right functions. So a lot of this is just like it's nearly like mental load of working with the fact that characters and numbers, we have to remember these things. So we are actually passing a character into an integer function, but it will work because this is expecting the integer to represent a letter. If it wasn't, then we may have a problem. But because it is, we can still work with it. So what this is doing is saying, check if this particular letter exists in this word. So it's going to do this function, and this function's either going to return the index where it found the last index where it found the letter, or a -1 if it did not find the letter. So found index is going to have a value that will be given by this check letter. We're really only checking whether this is in the word or not. So if it is in the word, then it's greater than or equal to 0. So if it's greater than or equal to 0, it's one of the indexes of the word, indices, sorry. And if it's -1, which is going to fail this check, then we're going to ignore it. So we're only going to add 1 to the number of letters we found if it gave us an index, which means we found the letter. So hopefully that explains what this line is doing. This line is calling this function. This function's up here. This function's going to give us back a number, and we're going to store that number here in found index. Then we're going to check whether that result was what we wanted or not. So hopefully that answers a bit of what you're saying. Oh, right, yes. I didn't read the second part of your question. The parameter is different to the check letter function. How is it possible? Yeah, it's only possible because we're kind of abusing the fact that a character is a number representation of a letter, which means it's actually an integer. It's actually, like, a character is actually an 8-bit integer, so it's actually interchangeable. Characters can be treated as numbers. Yeah, so that's the only reason why this works, where you can put a character here into this integer function. But this integer function is the thing that must be careful then, because if we're looking at things like their characters, then this function here has to understand that it's going to get a value passed in, which is only between 0 and 255 if we're going to pass in a character. But the good thing is an integer can definitely take values between 0 and 255 because they're capable of dealing with much bigger numbers than that. Hopefully that explains what's going on there. If people were wondering whether it was chicken purring, it was probably a car outside, yeah. And Lorenzo looked up string to lol. String to lol. string to L. Second argument points to a space in memory where you can put the string. Oh, right. So if we're reading a number with its only part of a string and we want to keep the rest of the string, so we can kind of consume the number off the front of a string and save the rest of it to then read it as a word, you can use that pointer to do other stuff with it. Yeah. Okay, that's cool. Yeah, but I think for the purposes of this course, when we're just converting things, we won't really be worried too much about using the extra bits on string to L. Oh, we didn't use string to L in this demo. That was in the other demo. Yep. Okay, do we have any other questions? I don't need this white space anymore. I always put that there so that the code is closer to the middle of the screen. Do we have any other questions about this code or about how we work with characters and strings? Brendan's asking, would it be possible to use strcomp in this code like for the check words function? Yes, it would. So this is in the challenge. There are more standard library functions that might be able to replace some of our code. See if you can discover them. You have discovered one. So where is it? I think there was a clue in here. String compare and other variations of it compare two strings. So you can actually have something that says this is how much of these two strings match or not. So you could look up these library functions and you can go, can we replace what Mark was doing, comparing two strings with each other, with something that actually does it? So strcomp, string compare, will give you a certain amount of information about whether two strings are the same, and some of its variations might actually be useful. So yes, Brendan, that is a good question, and it actually could help. Yeah. Lorenzo saying you're a bit behind in the... Oh, you were late and you're watching it through now, I think, are you? Oh, Sarah's asking, can I explain the parameter again? Okay, so this is interesting, right? So this is a character. This function is expecting an integer, right? So on instinct of just understanding the types are different, this doesn't seem to make sense. However, what gets passed into this function is not the entire variable. So the entire variable here would be an 8-bit number representing a letter, but it gets converted into a value before it gets put in. So let me go back to Paint again. I'm gonna start a new one. So, what was it called? Check letter. Is expecting two things. So an integer and a character array. So an integer is any whole number. And then when we call check letter from elsewhere, I am putting in, what was it? A character and a character array. So this one's easy because we know that's the same thing. But it's important to note that a character array doesn't go in there. The thing that gets passed in is the value of the character array. So the thing that gets passed in here is a memory address. So it matches because the character array here is expecting a memory address. This character array is a memory address. This one here is the different thing that we're saying, how can we give a character to an integer? So let's say this character, let's get into specifics. So let's say this character was, I'll do it in pink because they're usually in pink. It was the letter A. And the letter A is also the same as the number 97. I just memorized that because I've memorized some of the ASCII table. So this character gets passed in to this integer function. You don't get the character A going in. The only information that goes in there is 97. So because characters are represented as numbers, the thing that gets passed into the function is not the variable. Sorry, I'll change this so you can see where I'm pointing. It's not the variable, but it is the value that the variable is storing. And because the value that the character is storing is a 97, it goes in here, and this thing goes 97. Yeah, that's fine. I can read 97 like it's an integer. We're good. We'll continue, you know? And then in this function, it's up to me as the programmer to say, I was expecting that number to be within 0 and 255 and something I can use as a character. If I call this function and I type in the number 10,000 somewhere else, I can make an integer, make it value 10,000 and pass it in here. This function may not work the way we want it to. I mean, it'll still kind of work, but it's definitely not going to find 10,000 anywhere in a word, because a character array can never have as any of its elements the number 10,000, because they're all 0 to 255. So the interesting thing is, even though we're trying to smush a character into an integer, because of the value that the character stores is something that the integer can handle, that's okay. There are cases where this won't work, but this is one of those cases where C says, yeah, a character, I'm going to treat it as a number, so you can put characters into integer functions. If you try to put an integer into a character function, you have a problem, because the other way around gets a bit weird, because the integer is a 32-bit number and the character is an 8-bit number. So the 8-bit number can be represented with the 32-bit number, in a sense. So anything that you try to do with a character value, an integer can also do. But the integer can do things the character can't, so C won't like it if you try to go the opposite direction. So hopefully that gives you a bit more information, Sarah, about what's going on here. Why check letter is okay receiving a character. Because the character, while we think of it as a letter, C will think of it as its ASCII code, which is a number, and so we can transfer this in like this. This is actually really similar to here, where we were taking an input character as an integer, and then we were doing check letter using the input. Oh no, we were just using integers the whole way through. The other thing that we could do, which is interesting, is if I change this to a character, and up here as a character, pretty sure this thing will still work. Let me compile it and see if it does. Might get a warning. No, only the string length warning. So this function is just as happy taking an 8-bit integer, a character, as it is taking a 32-bit integer. So I'll change it back. Actually, I don't have to change it back. I can leave it like that. So we can take an integer and put it into a character function. Oh, so that does work. Yeah, it does work, but on certain integers it might break things. Yeah, so we can take an integer, put it into a character function, and we can take a character, put it into an integer function, because since they're both numbers in C, they're interchangeable to a certain extent. I don't want to say that as an absolute, because there are ways that can break. Lorenzo is asking, what is the difference between stir copy and stir n copy, and stir cat and stir n cat? As far as I know, the one with the n is counting things and giving back some information. I would have to look this up. Stir n copy, here is a C++ reference, but I think this will still give us information on C. Copy character string copies the first num characters from string of source to destination. Okay, so stir n copy will copy a specific number of letters, and I'm pretty sure that stir copy, it'll be here, we'll just copy them all and it won't have the number. Yeah, so stir copy copies the entire source to the destination, and stir n copy says you can tell me exactly how many letters to copy from one to the other. So they'll be slightly different because of that. Right. Lorenzo looked up strcomp. Strcomp is the comparison between two strings. We're actually going to look at this later. I think we're going to look at this next week. I can't remember. I know I remember teaching it, but I can't remember exactly which lecture we taught this in. Strcomp is really interesting. So it returns like the difference between two strings. So if they're the same, there's 0 difference between them, which is actually super annoying for a true-false function, because usually if a function has like true-false capability, I prefer it to have 0 for false and any other value for true. But strcomp, it actually flips it on its head, and it says 0 for the same, -1, I think, if the first one is lower than the second one, and +1 if the first one is higher than the second. And what that means is, if the letters are the same but some letters are different, it'll take the ASCII values of the two letters and it'll tell you which one is like lower or higher in its number value, which is interesting, and a little weird, because when you use the number value lower or higher, you could treat it as doing something like alphabetical ordering, but ASCII value is not alphabetical ordering. Because all the capital letters are in their own range and all the lowercase letters are in their own range, and then you go, okay, which way are we actually doing alphabetical ordering like that? So it's a little bit weird. So it's not exact. Yeah. Brendan, C is a boomer. I guess so. C, actually, C's like a, it's not a boomer. I think it's a Gen X. Because it was born in the late 70s. Anyway, there's like details we don't need to get into. But yeah, but C is old enough that it does weird things, where other languages, you just put a double equals with two strings next to each other. But because C doesn't technically have strings, it has arrays of characters, and you can't put a double equals between two arrays. Because remember that the array variable is just the address of where it is. So the contents of two arrays may be the same, but the double equals won't work. The double equals will just go, are you the same address as this? And then it will say, are these two exactly the same array? Not do they contain the same things. So lots of little subtleties there with that. Alan's asking, printf, fputs, putchar will be used together in most cases. I think it's rare to get this. It's very rare to use all of them at once. I mean, we could potentially have done all of this in a printf, because we could have just printed out the string in the printf. So there is actually a symbol for printing out a string, which is the %s. I don't use it that much because I don't want people to think too much about the %s, because if you use the %s in scanf, things break. Well, they don't break, but they're very risky, and I don't like people doing it. So I don't even show the %s most of the time. I use fputs. So you can use this, or you could have gotten away with just using a printf for things. When we're doing stuff, unfortunately with the printing, there's a lot of overlap between these functions. There's some really subtle and important things that some can do and others can't, which is why we need them all. But a lot of cases, you could get away with only using something like printf for everything, and just finding out your way of using the these % format strings to do different things. So yeah. You won't always see it used together like this. I just wanted to do this in the demo. Sometimes we'll use one or the other and stuff. Fputs will just be able to dump an array onto screen, an array of characters. So you could do all your manipulation in the array of characters and then dump it to screen using the fputs. So there's different ways of doing things. So Lorenzo's saying, if you compare a phrase in lowercase... Oh wait. Nope. You retracted the message. You must have read somewhere yourself what it meant. So Lorenzo's saying, if you compare a phrase in lowercase to the same phrase in uppercase, then the former is less than the latter. I think so. I think lowercase letters are first. So Sarah's asking, why against word to? So it is able to compare word to. Not sure what you're asking there, Sarah, but I'll go back to the code that we were looking at before, because you're wondering about this line here. So why against word 2? So what we're doing is we're comparing a letter from word 1 to the entirety of word 2. And that's what check letter is doing, is saying, is this letter in this word? So if this letter is in this word, then that's us saying that we found this letter in this word. So the whole idea we were doing when we were checking the words here with the rhyming was to see how similar two words were to each other. If the words were like, we're using a measure of whether the words are similar to each other by saying how many letters from one word did we find in the other word. So in order to do that, we'll loop through this word, and for every letter in this word, we check whether that letter exists in the other word. If it exists in the other word, then our count goes up. So all we were doing there is saying, check all the letters from word 1 against word 2. And so each letter we look at, we check if it's in word 2, and if it is, we count how many things we found there. And then that was our way of saying, check words is going to say, is every letter in word 1 somewhere in word 2? If every letter in word 1 is somewhere in word 2, then the return of this is going to be the same as the length of this word, because every letter added 1 to found letters. If it's only partial, then it will be less than that, but it will tell us exactly how many of these letters, well, not these, but the letters that were in word 1 ended up being in word 2 also. So it's not necessarily rhyming, but it's a step towards checking the similarity of those two words. Hopefully a lot of this explanation is helping a little bit to understand what we were doing and why we were doing it. Okay, I think that will do, I think, for questions there. We're half an hour over, so I think that's a good place to stop. Thanks for coming along, everyone. I'm glad that Chicken actually did say hi by the end of the lecture. And I will see you all on Wednesday at least. I will probably still be doing something Wednesday and Friday next week, but I mean, I'll see you there if you come along. If you want to take some time off and do other things, that's totally fine as well. It's all part of what Flexibility Week is. All that stuff will be recorded anyway, but you can totally get away with the course without watching either of those lectures if all you're doing is laser eye focus on the course itself, and just getting marks in the course. You can do that. Otherwise, stuff might be interesting for people. Okay. Sorry, Sarah, I'm gonna have to wrap it up here. But I think if you can probably talk to your tutor about that, or actually, that's not a bad thing to take to a help session. The help sessions are online, so you could go to a help session on Monday or Tuesday when they're on, and bring this code in and say, look, I don't understand how these things interact, and the tutor will be able to explain some stuff to you there. Sorry, I've just got to wrap it up now. Alright, goodbye all.